Hello everyone, this is Vijay Lakshmi Subnandi from WinMaths YouTube channel. Here, WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and various competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation well for various competitive exams. Okay, here in this session, we have to discuss the concept Venn diagram. Okay, here Venn diagram is named by the English logician, that is John Venn. He was given the great concept by the Venn diagrams. Okay, by the representation of Venn diagrams, we discuss the sets and some of the concepts in a easier way. Okay, here we discuss the concept now, that is Venn diagram named by the English logician John Venn in the year 1834. 1880. Okay, here usually the Venn diagrams are taken by the rectangles and using the closed curves. Usually, the closed curves are taken as a circle. Okay, the whole rectangle represents as a universal set, and the elements of these sets are written in their respective circle. For example, here the universal set containing the elements may be 1, 2, 3, 4. Okay, here I consider universal set containing the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, universal set containing the elements 1 to 10. Then I consider one set A containing the elements 4, 5, 6, and I have taken another one set as a B, that is 8, 9. Okay, I will write the elements here. First set containing the elements 4, 5, 6, and B containing the elements 8, 9. Totally, the whole rectangle represent as a universal set, that is, the elements are 1, 2, 3, 4, 5, 6, then 7, 8, 9. Okay, totally, there are, and last one is 10. All the elements are taken here. Okay, this is the general representation of the Venn diagram. Based on the Venn diagrams, we will discuss the operations on sets. Mainly, there are three operations are there. That is union of two sets, intersection of sets, and difference of sets. When we have to consider two or more sets by the comparison of these sets, we have discussed the operations. Okay. In earlier classes, we have learned how to perform the operations of addition, subtraction, multiplication, and division on numbers. Okay. We already know about the addition, subtractions, and multiplication of two numbers. Based on that operation, exactly in the set also, the operations will be discussed. Okay, here we will discuss the one by one operations here. That is, first one, union of two sets. Okay, union of two sets. For the union of two sets, we have to take an must and should consider two or more sets. Okay, I will consider two sets A and B. Based on the two sets, I will define the concept here. Let A and B are any two sets, then union of A and B is the set which consists of all the elements of A and all the elements of B. The common elements being taken only once, the symbol U is used to denote the union. Okay, here there are two sets, are there A and B. Okay, Then we have to consider the union of two sets. Usually, symbolically, we have to write the sets A union B. Okay. Here A be a set containing some elements. That is, there are some elements. And B be a containing some elements here. Okay. Then where the union of A and B is said that which consists of all the elements of A and all the elements of B. Okay, we have to add both the elements and the common elements being taken only once. Okay, then the symbol usually denoted as a union. That is, we can read it as a union B. Okay, that is, for example, I will consider the examples here. That is, let A be a set and B be a set. Okay, we have to write a union B. The definition A union B said we have to the A union B set containing both the elements of A and B. Here the elements containing A 2, 4, 6 and 8. Then the set containing B. The elements are 6, 10. 10, 12. Okay. Here 6, 8 already in there at set A. So don't write another one time because the common elements are taken only once. That's why I have taken 6, 8 once only. Then 10, 12. Now it is the A union B. Okay. Otherwise, simply first you have to take common elements between these two sets. 6 and 8 are their common elements. So, usually have to write A union B is equal to 2, 4. Okay, common elements 6, 8. After that, the common elements are already written. The left elements are 10 and like this. This is also same method for writing the union. Okay. Now, let us discuss the next one example. Here let A is a set containing the elements A, E, I, O, U and B is a set containing A, I, U. Okay, we have to write the A union B first. Okay, what are the elements present in set A? A, E, I, O, U and the set B containing A. Here also A is common in there. I will write once. Then I. Here also I common element I have written. Then U. U is also common element I have written. Okay. Now they given another one statement here. Have to show that A union B is equal to A. Okay. Now here already we have given or the result for getting A union B is A E I O U. I will replace A E I O U by A only because the set A containing all the elements A E I O U. That's why I replace the set by elements by set. That time A union B is equal to A. This is the solution. Okay. Now let us discuss the more example. After that, the statement and examples are clarified by you. Based on example, I will define a definition for union is the union of two sets A and B is the set C, which consists of all the elements which are either in A or in B, including those which are in both. It means have to collect A union B. Okay. Have to collect all the elements of A and all the elements of B. Then have to write the common element once. Or else this definition say either we have to write the elements in A or B. Include those elements including in both the sets. Okay. That is in symbolically, I can write A union B such that x belongs to A or x belongs to B. Means all the elements which is present in A or all the elements which is present in B, then we have to take it as a union B. Okay, either in A or B. Okay, in symbolically we have to write the definition is A union B is equal to x such that x belongs to A or x belongs to B. You have to write any one definition out of this. It will be correct for that. The union of two sets can be represented by the Venn diagram. Okay. Here, this is the representation of the Venn diagram. A be a set and B be a set. Okay. The sum of the elements will be present in both the sets. I will write. The shaded region shows the union of sets. Okay. The shaded portion in the figure represents the A union B. This is the representation of the A union B. Okay. Now, for this one representation, I will take one example here. Let A be a set containing the elements A, E, O and I, I, O. Now, I can write the elements here. The set containing the first have to take the common elements. A and O are the common elements. I have written here A and O. The set containing the elements A, E, O. Here I can write the E here, and the set containing the elements A, I, O. So I have written here. Okay. This is the representation of the examples in a Venn diagram. Now let us move on the some properties. Okay, we will discuss the properties regarding the operations of union sets. Let us take the first one operation, that is A union B is equal to B union A. Okay, A union B is equal to B union A. It is the commutative law. So I will take one example. Based on the example, I will solve the property here. Now, just I will take one example. The elements 1, 2, 3, 4. And the set B containing the elements 4, 5, 6, 7. Okay. Now, A union B is. First have to write the elements in set A. 1, 2, 3, 4. Okay. Here 4 is the common element. I have written once. And the set of elements in B 5, 6 and 7. Okay. This is the A union B. Now again, LHS part is over. Okay. I will take it as a equation number 1. That is A union B is equal to 1, 2, 3, 4, 5, 6, 7. Now I have written B union A. First I will consider the elements in set B 4, 5, 6, 7. Then I have written set A 1, 2, 3, 4 already written. Okay. Then close the bracket. This is option number 2. We already know the concept equal set. Based on the equal set concept, I will check equation 1 and 2 is equal or not. Here there is a element 1, here also 1, 2, 3, 3, 4, 4. 5, 5, 6, 6, 7, 7. Okay. Then I will say A union B is equal to B union A. From 1 and 2. What I say? From 1 and 2. A union B is equal to B union A. That is commutative law holds for the union of the operations. Commutative law holds for the operations of union. Okay. Similarly, you have to check the all four properties here. Okay. Here, take another one set C. H 9. Okay. First, have to consider the LHS part. After that, you have to write the RHS part. Okay. You only have to solve the properties. Okay. Now, I will move on the next concept, intersection of sets. Intersection means have to take common elements. Union means have to write all the elements in both the set and common elements have to write only once. Intersection means have to write the only common elements. The intersection of sets A and B is the set of all elements which are common to both A and B. For the intersection, we have to use the symbol denote the intersection. Okay. The intersection of two sets A and B is the set of all those elements which are belongs to both A and B. Okay. The elements which is present in both the set, that is common element between the two sets, is called as a intersection of sets. Symbolically, we have write the A intersection B is equal to X such that X be an element which is belongs to A set and X be an element which is belongs to B set also. Okay. I will take one example here. Let A be a set containing 2, 4, 6, 8 and B be a set containing 6, 8, 10, 12. Have to find the A intersection B. Okay. Intersection means have to take the common elements between these two sets. Here 6 is common to both sets. Okay. 6 is present in both set and 8 is also present in both set. There are only two elements which is present in both sets. Therefore, A intersection B will be 6, 4, 8. Okay. This is okay. And now I will take the another one example. Example number 70. Let A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And B be a set containing the elements 2, 3, 5, 7. Have to find the A intersection B. And hence show that A intersection B is equal to B. Okay. Now here have to check the common elements between the set A and B. Here 2 is common in both sets, yes. And 3 here common, 5 is also common. Then another one element 7. Therefore, A intersection B is equal to, what are the common elements? 2, 3, 5 and 7. Therefore, A intersection B is equal to 2, 3, 5, 7. Now, all the elements 2, 3, 5, 7 represents the set B. The elements 2, 3, 5, 7 represents the set B. That's why I can replace elements by the set. That is A intersection B is equal to 2. This is the solution of the given problem. Now, we will define the intersection here. The intersection of two sets A and B is the set of all those elements which are belongs to both A and B, or else the elements which is present in both A and B. This is the representation of the Venn diagram. Okay, the shaded region, the only common region is represents the A intersection B. If A and B are two sets such that A intersection B is equal to null set, then A and B are called the disjoint set. Okay, it means if I will take one example. First, I will clarify the Venn diagram here. A B is set containing the elements A, B, C, and set B, D containing the elements D, C, D. Now, how to check the A intersection B here? The elements which are present in both sets are B, C. Okay, only the two elements B and C are common to both the sets. So, A intersection B can be represented in a vector or Venn diagram. Representation in Venn diagram, the elements B and D. Okay, here hold the set containing the elements A, B, C, and the element which are present in set B are B, C, D. Here the only two elements which is common to both, that is B and C. This is the representation of the Venn diagram for intersection. Now there is a one important concept here. If, for example, in this example, the elements which is common in both the sets, if there is no common element between the any two sets, then the result will be null set. Okay, that time both sets are called as a disjoint set. For example, here let A be a set containing the elements A, B, C, and the set B containing the elements D, E, F. Okay. Now we have to take the A intersection B. Okay. A intersection B is, have to check the common element between the two sets. Here A set containing A, B, C, B set containing D, E, F. There is no common element between these two sets. That time it is the null set. There is no common element. Or else I can write A intersection B by the null representation of the null set. Okay, pi represents the null set. That time when these type of sets they have given, then both A and B are called it as a disjoints. If common elements are present, then it is a A intersection B. If there is no common elements, then there is a operation disjoint sets. It is clear. The representation of the Venn diagram here, A be a set and B be a set. Here it is a universal set. And then A be a set containing the elements and B. A containing the elements A, B, C, and B containing the elements D, E, F. There is no common elements, therefore it is a disjoint set. Okay, let us move on the next concept. Okay, here the representation of the disjoint set. Now take the another one example here. Let A be a set containing the elements 2, 4, 6, 8 and B be a set containing the elements 1, 3, 5, 7. The representation of the Venn diagram is a set 2 containing A containing the elements 2, 4, 6, 8 and B be a containing elements 1, 3, 5, 7. Okay, there is no common elements. Therefore, this is the representation of the disjoint sets. Okay, now let's move on the concept. Some properties of operations of the intersection. Okay, here also there are 5 properties out there. First one is A intersection B. Okay, there is a first property A intersection B is equal to B intersection A. If LHS and RHS is true, then it holds the commutative law. Okay. If three sets are taken, that time A intersection of B, then intersection C is equal to, or else first have to check the B intersection C. After that A intersection, then it holds the associative law. Then empty set intersection A is also empty. Union of intersection A is equal to A. This one is called as the law of union or law of empty sets. Then A intersection A is also A. Okay, this is called the idempotent law. Then the fifth one law is the distributive law. Okay, here A intersection of B union C is equal to A intersection of B union A intersection of C. Distributive law, or it can be read it as a intersection distributes over the union. Okay, now we'll have to solve the one example here. Okay, I will discuss one example for the associative law. Okay, here first I will consider the three sets containing the elements 1, 2, 3, and set B containing the elements 4, 5, 6, and C containing the elements 3, 5, 7. Okay, based on these three sets, I will take the associative. First, I will consider the left hand side, that is A intersection B intersection C. Now, first I will take A intersection B. Common elements between these two sets is, in between these two sets, there is no common element 1, 2, 3 and 4, 5, 6. There is no common element here. So I will write it as a null set. Then here there is an intersection and the set C containing the elements 3, 5 and 7. Okay. Then there is no element intersection between 3, 5, 7. Here basically this containing set containing there is no element. So there is no common element, because here already we discussed the property here. Null set with any set, the result is null set. Therefore, according to the law of null set, I can write the result null set. Then I will take the RHS part. Okay, RHS part is A intersection B intersections. Okay, first I will write the A set here containing the elements 1, 2, 3. Okay, intersection of. So we have to write the intersection of B intersection of C. Okay, in between these two sets, have to write the common element. There is only the common element 5 is there. Okay, there is only the one common element 5. Now I will take the intersection of these two sets 1, 2, 3, here 5. There is no common element. Therefore, A intersection B intersection is null set. From these two results, from 1 and 2, or from LHS and RHS result, both are equal. Okay, then have to check other 4 result by using the example, or else we can take any other example. Based on that example, have to check the property one by one. Okay, now let us move on the next concept, that is difference of sets. Difference of sets. The difference of sets A and B in this order is the set of elements which belongs to A but not B. Okay. It is symbolically we have to write A minus B and read it as A minus B. That is the difference of set usually represented by the A minus B. Okay, it means an element X which is present in A. The element which is present in A but not in B. The element X not belongs to B. Okay, that is called the A minus B. Difference the elements which are present in A but not in B. Okay, this is the representation of the difference of sets. Okay, here the green portion represents the A minus B here, and here the green position represents the B minus A. Okay, it means the elements which are present in A only but not B. And here B minus A means the elements which are present in set B only, not A. Okay, we will discuss the difference of sets one by one by using the example. Okay, there are two sets are there. Set A containing the elements 1, 2, 3, 4, 5, 6 and set B containing the elements 2, 4, 6, 8. Okay, first have to neglect the common elements here. Okay, here 2 is the common, so I will neglect it. Then 4 is also common. Okay, have to neglect it. 6 is also common element. Have to neglect it. Okay, here have to neglect the common elements. Okay, after that A minus B is A minus B. What are the elements which are present in A? After neglecting the common elements 1, 3, 5. This is the A minus B. Then B minus A means have to check the elements. Common other than the common elements is only the element is H. Okay. A minus B means the elements which are present in A only. Okay, that is 1, 3, 5. Then the elements which are present in B minus A is only 8. So in difference of set, first have to take the common elements and first have to neglect it. After that, have to write the difference of sets. Next, here there is an example number 19. Let V be a set containing the elements A, E, I, O, U and B be a set containing the elements A, E, I, A, U. Have to check the V minus B. Here V minus B and B minus V. Okay. First, have to neglect the common elements. Here V set I have written A, E, I, O, U minus A, I, K, U. Okay. Have to neglect the common elements first. A and A. Then I, U, U. What is the element which is present in V set? E. And this is the V minus B. And here, first have to write the set B. A, I, K, U minus A, E, I, O, U. Okay. Here also neglect the common elements. Okay. After that, have to consider the set B. What are the elements? The only one elements left here. Okay. This is the B minus V is set containing the element K. We note that V minus D not equal to B minus U. Okay. When checking the V minus D and B minus V here. Okay. V minus B has the result. Okay. Here V minus B has the result EO and B minus B have result the element K only. Okay. Both are not equal because here both the results are different. Using the set builder notation, we have to write the definition. Difference is a minus b such that x b belongs to a and x does not belongs to b. Okay, it means there is an element x which is belongs to a but not in b. That is a minus b. Then the difference of two sets A and B can be represented by the Venn diagrams. Okay, here we already discussed the Venn diagram. If A minus B means the elements which is present in A but not in B. Okay, this is the region. I will consider the region here. Only the this part is the A minus. Okay. Now let us move on to the concept. Or there is a one remark here. The sets A minus B, A intersection B, and B minus A. Okay. These are mutually disjoint sets. That is, the intersection of any of these two sets is the null set. Okay. Here A minus B. Okay. We have to check these three result here based on this example. Okay. In place of V, I can take the A. So I will take A minus B here. A minus B means here I will take the common elements A, I, U. A minus B, the result is U, O. And B minus A, the result is A. Because here I will neglect the common elements. Then A intersection B means I have to write the common elements. What are the common elements? A, I, U. These are the common elements. Okay. While consider these three sets. Okay. While consider these three sets, in between any sets, we will take there is no common element. While considering A minus B and B minus C. Okay. The elements I roll and K. There is no common elements. Therefore, these are the disjoint sets. Okay. Again, I will consider these two sets. B minus A and A intersection B. B minus A and A intersection B. A in B. Here also there is no common element. Therefore, this is also disjoint sets. And again, I will consider first and last. A minus B and A intersection B. Okay, that is EO and A intersection B will be AIU. Here also there is no common element. Therefore, this is also disjoint sets. Therefore, the remark is the sets A minus B, A intersection B, B minus A are mutually disjoint sets. Okay. The intersection of any of these two sets is the null set. We have proved here. Okay. We have proved here. The result will be the null set. Up to this much, I have completed the concepts, or I will discuss the concept operations on set, that is union, intersection, disjoint set, and difference of sets. Okay. Based on these operations, we will discuss the examples one by one on the exercise problems in next session. If you really like my classes, please like, share, and subscribe. Otherwise, if you have any doubt regarding the classes and example, please write your doubt on comment box. Thank you. Thank you for watching my videos.